Hi guys, so welcome back to our new math tutorial. Now this time we'll learn how to add and subtract rational algebraic expression. Now before we proceed with our example, the first thing that we need to do is to take note of these two things. Now we have two cases of rational algebraic expression. They have the similar denominator and also same denominator. Now let's focus first on the same denominator. Remember class, remember the moment we have the same denominator in a fraction, in arithmetic fraction, the only thing that we need to do is to copy the denominator, then simplify the numerators. That's why you have n over d, positive, negative, or plus minus m over d is equal to, you copy the denominator, followed by you copy the numerator, then you can now simplify them. Now, how about if it's the similar denominator? In the similar denominator, there is a need for us to find the LCD. We need to find the LCD, and after that, to get the numerator, after getting the LCD, you need to have LCD divided by denominator multiplied to your numerator, which is n, plus minus, followed by the second fraction here, LCD divided by the denominator, then multiply to the numerator. So those are the things that we need to consider, especially if you're adding and subtracting rational algebraic expression. And again, how we deal with arithmetic fraction is also the same how we deal with rational algebraic expression. Now let's go ahead and try example number 1. I have here 5 examples that we can try, and so that we'll be able to learn how to add and subtract rational algebraic expression. Now let's move on to number 1. So we have a over 6 plus 3 over 6. Let's apply the same law. As you can observe that we have the same denominator, which is 6. Therefore, the only thing that we need to do is to copy the denominator. We can now write our two fraction into one fraction, which is same denominator. Then we just need to copy the numerator, which is a plus 3a. And after that, we just need to simplify. If we can still simplify, then yes, we can simplify. But if it's not, then there's no need for us to simplify. Okay? Now, in this case, we can still simplify this. So we can actually remove the common factor, which is a. So we have a here. And then let's get the remaining factor. A divided by a, that's 1. Plus 3a divided by a is 3. All over 6. Then simplify. 1 plus 3 is 4. So that will become 4a all over 6. Then reduce this. Cancel this one. So this will become 2. And this one will become 3. So therefore, the final answer will be 2a all over 3. Now, you might be wondering what we did here. This is the greatest common monomial factoring. They are in common in terms of variable, so there is a need for us to take out the common variable, which is a, and then we get the remaining factor by just simply dividing the polynomial to the GCF, which is a divided by a is 1, 3a divided by a is 3. That's the greatest common monomial factoring. And then we can now simplify this. 1 plus 3 is 4. Then a times 4 is 4a. And we can now cancel 4 and 6. They are common in terms of 2. So we have 4 divided by 2 is 2. 6 divided by 2 is 3. And then we can now simply copy our final answer, which is 2a over 3. Now, let's try another example number 2. The same process, as you can observe that both denominators are the same, so there's only a need for us to copy this. So we just need to copy our denominator, which is 6c, followed by we copy the numerator, which is 3a minus b plus 6a plus 5b. Then let's combine like terms. What are the like terms here? So we have 3a followed by plus 6a. So simplify that. The answer is 9a. Followed by negative b plus 5b. The answer is positive 4b. all over 6c. Now, the question is, can we still simplify this? The answer is no. So therefore, this will become your final answer. Since we cannot factor a and 9 and 4, they don't have any common factor, so we cannot get their GCF. A and B also not common, so we cannot get their GCF. So therefore, this will become your final answer. Again, we only simplify if we can simplify. If the final answer upon applying the operation is already simplified, so there's no need for us to force ourselves to simplify the expression. Now, let's move on to the next example number 3. As you can observe that our denominators are different. We have x here, followed by 2x, followed by 3x. Now, if that's the case, there is a need for us to find the least common denominator. Now, let's just need to observe our denominators here. Our denominators have common in terms of x, so therefore that will become your LCD in terms of x. Now, what will be the LCD in terms of numerical coefficient? As you can observe, the numerical coefficient of the first denominator is 1, then followed by 2 and 3. 2 and 3 is not divisible to each other, so there's a need for us to multiply them. So 2 times 3 is 6. And that will be the LCD of our fraction. Now, remember this part here, we need to get the numerator by getting the LCD divided by the first denominator, then multiply to the first numerator, then the operation, then do the same thing to your other fraction. Okay, so let's have 6x divided by x. The answer is 6. Then you need to multiply that to 3, which is 18, plus 6x divided by 2x. This will become 3 times 5 is 15. Next, LCD multiplied divided by to the new denominator. This will become 2 times negative 11 is negative 22. Okay, so first LCD divided by denominator, which is 6, and multiply to the numerator, so 6 times 3 is 18, and do the same thing to the others, and then we just need to simplify the following or the numerator. We have 6x, 18 plus 15 is 33. We have 33 minus 22. Then 33 minus 22, the answer is 11 over 6x. Now, 11 and 6x didn't have any common factor, so therefore, your final answer, therefore, this will be your final answer. Okay, let's go ahead and try this example number 4 and number 5. Now, this actually is a different case because as you can observe that our denominators are now binomials. So there is a need for us to factor first our denominator before we can proceed to the LCD or before we can find the LCD. So let's factor first our denominator. Let's copy 5m all over. Let's get the factor of this one. As you can observe that the first term is a perfect square, and 4 is a perfect square, and n is also a perfect square. Therefore, this is an example of a difference of two squares. Therefore, the factor for this is m minus 2n times m minus positive 2n plus 4 times n minus 2n. After making sure that our denominator is already in a factored form, we can now find the LCD. The LCD for this one, as you can observe, that we have two common factors here, which is m minus 2n and also m minus 2n. So we just need to write them as one factor, m minus 2m times, remember, whatever is not common, you just need to multiply it to their common factor, which is m plus 2n. Then, let's do the same thing here. LCD divided by denominator, then multiply to numerator, and we do this both fractions. So LCD, this one, LCD divided by to denominator, so we can cancel m minus 2n, also m plus 2n, so will give us 1. So 1, this will give us 1, then 1 times 5 is 5m. So therefore we have 5m here. Plus, same factor, same process I mean, the LCD divided by the denominator, so we can cancel m minus 2n, so we'll have m plus 2n. Then multiply to your numerator, it will give you us 4 times n plus 2n. Okay, and let's simplify our rational algebraic expressions. We have 5m plus 4, distribute 4 to your parentheses, so we have 4m plus 8n all over m minus 2 times m plus 2n. Where's the n here? Alright. Next, after this simplify, 5m plus 4m is 9m plus 8n all over m minus 2n times m plus 2n. And as you can observe that we can no longer cancel here because 9 and 8 doesn't have any common factors. The same m and n is also not common. So therefore, there's no need for us to simplify. It means that this is now the final answer of your quadratic equation. Okay? I mean, this is the final answer of the rational algebraic expression. Okay, now let's try example number 5. Example number 4 and example number 5 has the same process. So there's a need for us to get the factors of these two. So we have 3 over, same, this is a difference of 2 squares, so a plus b times a minus b minus 2 times a plus b. After that, we can now get their LCD. The LCD for this one, as you can observe, we still have the same common factor, which is a plus b and also a plus b. So we can just write that as one factor. So we have a plus b times the not common factor, which is a minus b. Now, the same process, let's divide LCD divided by numerator, multiply to the numerator. Okay? A plus b times a minus b divided by a plus b times a minus b. So we can cancel that. So we can cancel this, which is 1. So 1 times 3 is equal to 3. So we have our first numerator, which is 3, minus a minus b, a plus b times a minus b divided by a plus b, which is your second denominator. So we can cancel this, bring down a plus b. So a plus b times negative 2a, so negative 2 times a is negative 2a minus 2b. Okay? And the next step that we need to do is to rewrite your equations. We have negative 2a minus 2b minus 3. Okay? As you can observe, negative 2a minus 2b has in common, so we can actually factor that out. So it will give us negative 2, that's their common, minus a plus b minus 3 all over a plus b times a minus b. So we can now cancel a plus b. We can now cancel a plus b and also a plus b here. So bring down negative 2 minus 3 all over a minus b. Simplify. So this is negative 5 all over. Let's rewrite it here. Is equal to negative 5 all over a minus b. And that's your final answer. Okay, so that's it. That's how you add and subtract rational algebraic expression. And I guess that's all for today, and I'll see you in the next video. Bye!